Hey everyone, and welcome. Today, we are going on one of the greatest journeys of all time, the story of how we figured out our cosmic address. It's an incredible tale that takes us from thinking we were the absolute center of everything to realizing we're just passengers on a tiny little rock in a universe that is so much bigger and, honestly, so much weirder than we ever could have imagined. Let's dive in.
So, the big question is, how did we do it? How do we figure all this out? Well, this wasn't some single aha moment, not at all. It was more like a massive detective story, one that unfolded over thousands of years. Every new clue was a fresh observation, and every new piece of technology, that was like a brand new magnifying glass, bringing the cosmic truth into clearer and clearer focus.
Okay, so our story has to start with a picture of the universe that for literally thousands of years just made perfect sense, the Earth-centered system. And it's really easy to look back and laugh now, but you have to understand, this wasn't some foolish idea. Based on everything you could see and feel with your own senses, it was the only logical conclusion you could come to.
And I mean, the evidence for it was all around you. Just put yourself in their shoes for a second. You don't feel the Earth hurtling through space, right? If you drop something, it falls straight down, not sideways. And when you look up at the night sky, the stars seem totally fixed in their patterns. For pretty much all of ancient history, all the signs pointed to one simple, inescapable conclusion. We're stationary, and the heavens revolve around us.
But, there was one big nagging problem. A few of the stars didn't behave. The planets, they seemed to wander across the sky, and sometimes they'd even appear to move backward. So to solve this little puzzle, astronomers came up with this really ingenious, if kind of crazy solution: epicycles. Just picture this. A planet is moving in a little circle, while the center of that circle is moving along a much bigger circle around the Earth. Yeah, it was messy, it was complicated, but hey, it made the math work.
So for almost 1,500 years, that Earth-centered view with all its complicated epicycles was the law of the land. But then, a single invention came along and just shattered everything. We're talking about the telescope. It was like a key that unlocked a totally new reality, one that showed us things that flew right in the face of what common sense had told us for millennia.
And this, right here, set the stage for one of the greatest scientific showdowns in all of history. In one corner, you have the established champion, the Ptolemaic System, and in the other, this radical new challenger proposed by Copernicus, a sun-centered or heliocentric system, where the Earth was demoted to just another planet. Now at first, his model wasn't really any more accurate, but it planted the seed of a revolution.
And boy, once that seed was planted, things started moving incredibly fast. So 1543, Copernicus drops his bombshell idea. Just over 50 years later, boom, the telescope is invented. By 1610, Galileo is using it to find hard evidence that just can't be ignored. And then, just 9 years after that, Kepler figures out the orbits aren't perfect circles at all, they're ellipses. In the span of a single lifetime, the entire old universe was just crumbling to pieces.
Galileo's observations were really the killer blows. I mean, he pointed his telescope at Jupiter and saw moons orbiting it, which was absolute proof that not everything in the universe circled the Earth. He saw Venus going through phases, just like our moon does, something that was totally impossible in the old Earth-centered model. And maybe most shocking of all, he saw that the heavens weren't these perfect, pristine spheres. The moon had craters and mountains. They were real places.
So, the Earth-centered model was broken. The sun-centered one was clearly the way to go. But a huge question remained. Why did it work? Why do planets orbit the sun in the first place? And why don't we all get flung off a spinning Earth? Well, that's when Sir Isaac Newton steps onto the stage, ready to write the universal rulebook.
What made Newton's work so mind-blowingly powerful was that he created a single, unified theory for everything. His law of gravity wasn't just for falling apples here on Earth, it was the exact same force that was holding the moon in orbit around us. His laws of motion explained not only why planets keep moving, but also why we stay put on a spinning planet. And with calculus, which he basically invented for this, he gave science the language to describe this whole cosmic clockwork with absolutely stunning precision. And if you want the ultimate proof of just how powerful his system was, look no further than the discovery of Neptune in 1846. Astronomers noticed that the planet Uranus was wobbling a bit in its orbit. It wasn't quite following Newton's rules. So they used his laws to calculate exactly where some unseen, unknown planet had to be, pulling on it with its gravity. They pointed their telescopes to that precise spot in the sky and, boom, there it was. They found a planet with math.
For more than 200 years, it really seemed like the puzzle was solved.
The universe was this grand, predictable machine, and Newton had given us the instruction manual. It was an absolute triumph of human intellect. But as our instruments got even better, even more precise, one tiny little nagging detail just wouldn't fit the model.
And that tiny little flaw? It was in the orbit of Mercury, the planet closest to the Sun. It wobbled just a tiny bit more than Newton's perfect laws could account for. It was a crack in the clockwork, and it would take another once-in-a-generation genius, Albert Einstein, to not just patch that crack, but to completely rebuild the clock from the ground up.
Now, this is maybe the biggest conceptual leap in our entire story. Einstein comes along and says, what if gravity isn't a force that pulls things at all? Instead, he proposed that massive objects like the Sun literally bend and warp the very fabric of space-time around them, kind of like a bowling ball sitting on a trampoline. So planets like Earth aren't being pulled by the Sun, they're just rolling along the straightest possible path through this newly curved, four-dimensional reality.
And the proof was in the pudding. When Einstein actually did the math, his radical new theory of general relativity predicted Mercury's weird little wobble perfectly. It succeeded precisely where Newton's incredibly trusted laws had failed for decades. This wasn't just a new idea. It was a deeper, more accurate description of how the universe actually works.
So when you take a step back and look at this whole amazing story, a really clear pattern starts to emerge. This journey from an Earth-centered cosmos to a warped spacetime wasn't random. You could almost say it was inevitable. The path forward was always lit by our own inventions. Our understanding has always been a direct reflection of our ability to see.
You can break it down pretty simply. When all we had was the naked eye, the Earth-centered universe was the only thing that made sense. Then, the telescope comes along, reveals a ton of new facts, and that demands a better model, which we got with the Newtonian system. And finally, even more precise instruments found the tiny flaws in that model, which paved the way for Einstein. Each giant leap in our understanding was pushed by a leap in the tools we built.
And that brings us right up to today and one final, really thrilling question. Right now, with instruments like the James Webb Space Telescope, we are building incredible new eyes to see the universe in ways we never, ever could before. So it makes you wonder, what tiny flaws in our current understanding are they starting to reveal? What new, even stranger universe are they on the verge of showing us next?